In the previous videos, we calculated the averages of various properties by just relating that to the probabilities of microstates for an ensemble or group of molecules. Mathematically, what we did is we calculated what's known as the ensemble average, in which the mean of our property was equal to this. So we had the value of a property for some state I and the probability of some state I as well. All right, this is how we defined the average of some property. Alternatively, we could have defined the average in terms of time, right? Such that we could just take a single molecule and we can measure the property X of that single molecule over some period of time. So for a single molecule over some period of time tau. Okay? And so that would be calculating what's known as the time average. Right? So the mean, the time average, would be equal to the limit as that period of time goes to infinity, and it involves this sort of integral. Okay? All right? And so that would be the definition of the time average. And so this brings up the question. We have the ensemble average and the time average. That brings up the question on which average is better. Right? So for a given situation, which one should we use? Fortunately, in thermodynamics, we don't really have to answer that question, because at thermodynamic equilibrium, the ensemble average and the time average are exactly the same. So it doesn't matter. And so essentially, if a system is at equilibrium, if you measure the property of a bunch of different molecules, that would be the same as measuring the properties of a single molecule over some period of time. Okay? And so if this holds true, we would describe the system as being ergodic. Right? So all ergodic means is that the ensemble average is exactly equal to the time average. In contrast, if a system is not at equilibrium, then the ensemble average is not equal to the time average. Right? If this is the case, we would say that the system is non-ergodic. Okay? All right, so in general, systems that are at equilibrium are ergodic, and systems not at equilibrium are non-ergodic.